Okay, combining functions. Now let's review how to combine functions and some of the steps and processes that go along with it. As always with tutorials, I will not answer questions or watch the videos unless I feel like the questions are beneficial or important. Then, of course, I'll go ahead and answer the question. So let's take a look at what we have next. Okay. Now this question, I will have you do the question on your own and we'll go from there. So introduction, we'll pass that video. So combining functions is it's pretty simple because you're just taking two equations basically and putting them together. It's kind of the simple term. So arithmetic options that you use, addition, subtraction, multiplication, or division, new function types. Now here's just some examples. We've already gone over some of these. Linear, absolute value, exponential, quadratic, cubic, polynomial, odd-powered polynomial. So this is the first one's even power. Next one is odd-powered, square root, cube root, logarithmic. Okay. So if I were you, I'd bookmark this. So you save this right here. Bookmark this website. It'll come in handy for the future. And we hit done like this. It's bookmarked. So linear, for an example, is the graph is a straight line. And the function can only have one y-intercept and one x-intercept. That's it. And when the slope is 0, the function may not have an x-intercept. So there's just some brief things about linear. Oh, it does not have symmetry either. Now, absolute value, the function is a v-shaped and symmetric about the vertex. So see how it's a v-shape like this? That's what that means. The function can be represented by a piecewise linear function. And the graph, the function will only have one y-intercept, but it can have 1, 2, or no x-intercepts. It really just depends how the v-shape is located on the graph. Now, exponential this will show growth or decay, meaning rapidly increases, like it constantly goes up, or it's rapidly decreasing. All right. So this is a U-shaped graph, symmetric about the vertex. So this graph is symmetric. That means that you could fold it up like a piece of paper, fold it in half, and it's the same thing, same concept. Quadratic functions have one y-intercept, but they can have 1, 2, or no x-intercept. Again, it really depends how it's located on the graph. Cubic, it's kind of a the graph rises at a decreasing rate, flattens out, rises again, increasing. Kind of looks like an upside down, turn backwards S type thing. Even powered polynomial, parent function of any even powered polynomial is symmetric. So basically, again, you fold it in half, same thing. Okay. Odd powered polynomial, there's no symmetry in this, kind of the same concept as our cubic function. Square root, kind of just a line that's going across. Doesn't include negative or negative x or y values. No symmetry with this one either. Cube root function. Now this one looks like a stretched out S. The graph is an S shaped and reflection of the cubic parent function is across the line y equals x. Logarithmic. Oh, okay. So this function is like it starts off and it curves kind of upward, kind of levels out. So let's go back here. All right, operations on functions. So here we have adding functions and we have, let's see, what next? So here's kind of, it shows an example how to combine the two functions and what needs to be done. And there you have it. So check the solution. Okay, so substitute. Basically, if it gives you a number for x or f of x or g of x or whatever it is, put that number, so 3, for an example, put that number in for x, then you calculate it all out, and here's the result of the function, or the answer. Subtracting is kind of the same process. I will do a mini lesson on this as well, so it's a little bit, so I break it down just a little bit more, so it's a little less confusing. But again, it's substitute the 7 for x, plug in the 7 for x, and yada, 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 go all the way down, and there you have it. So the result of g minus, or f minus g times 7 is negative 46. So basically, you're just plugging in that number 7 for x again. Multiplying, you probably guessed it, it's kind of the same process as we go. So then check the solution. We're plugging in 5 for x here. Same thing, it goes all the way down, and we're doing a logarithmic function here. Properties of logarithmic, I have a separate lesson on this. I highly recommend that you go through and you watch that because it'll break down each rule and property of log functions. Dividing functions, you probably guessed it, probably the same concept. So again, we are putting in the number for x, combining the two functions out just like this. Okay. Combining functions. Okay, so this, I will have you do this on your own. Questions. But as you can see, I will kind of just talk about this one for just a sec. As you can see, it is pretty simple because you're just combining the like terms. So basically, we have the 3x to the third power, or cubed, plus 7x minus 26, and then we have g of x plus 2. Basically, all you're doing is just combining all of these like terms. That's where you get the 8x from, and that's where you get the 24 from, because we're just combining the two functions together, adding the like terms together. Modeling with combined functions. Okay, let's find out what happens next. So this understanding the concept, so the function p represents the time in hours it takes Dan to reach the peak. Okay, so that's basically what is going on here. He's going on a hike, and we're trying to figure out what's his hiking speed. X is representing the hiking speed and how long it's taking. So we fill out this nice little math problem for it. So let's go read this again. Function P represents time in hours it takes Dan to reach the peak. Function B represents the time in hours it takes Dan to reach base camp. And notice that the only difference in the two functions is the denominator. Okay, so as you can see, the denominator is different in both of them. So we recall the relationship between d equals rt, or t equals d divided by r. And again, this is distance, time, rate, or speed. So then we have to figure out, since it's given that Dan hikes a total of 8 miles, the denominator of each function represents the speed. So we want to figure out how long it takes him, basically. Subtracting functions, all right? Kind of the same process. We're just combining them together. And then you factor it out using the greatest common factor, and then that will get you the answer that you need. Questions, I'll let you solve this one. Multiplying functions, same concept. Factoring it out, and we are combining the two things together. Dividing functions, similar concept. Combining them, dividing them out together. So then here's what you would do for this one. Okay, the questions. Yeah, this question, I will have you do this on your own. Hopefully that clears it up a little bit for you. And additional resources, recommend that you check this out. It gives you some great examples on Khan Academy of combining functions and a couple other things as well. All right, hopefully that cleared it up for you.